Hello friends, this is lesson 3 of Big Data Hadoop with Python. So in this lesson we are going to cover the following topics, and the first topic is normal distributed file system. Then we'll talk about what is Hadoop. Then I will install GDK. Then you will easily understand the difference between Hadoop environment and normal distributed file system. So let's start with the first topic. So the first topic is normal distributed file system. Before going to the Hadoop environment or Hadoop distributed file system, so it is better to first understand what is normal distributed file system and how the normal distributed file system is different from Hadoop environment. Now, as you know, in distributed file systems, both the data and computations are shared or distributed to a set of nodes, and the aim is to meet the following requirements. So this is the main aim, or we can say the main purpose of distributed file system. There we share both the data and computation. So in normal distributed file system, friends, the client sends the request to the server. So the server accepts or rejects the request. If the request is accepted by the server, so the client can send the data to the server, and then the server will process the data, execute the data, and any computation is there, any complex computation is there, that computation is done, and then the result is sent back to the client. This you have to remember, friends. And the main purpose is actually to meet the following requirements. These are the requirements here: scalability, fault tolerance, and recoverability. And scalability, increasing the number of machines should result in linear increase in processing capacity and storage. If it is normal distributed file system, friends, whenever we are increasing the number of machines, means the number of servers, so definitely there is a linear increase in processing capacity and also size of storage. For example, let me give you an example. If we have 3 servers in normal distributed file systems, so it means we have 3 processors and we have 3 RAMs. Maybe the size is how much the size is itself. So when we increase the number to 5 servers, so definitely we have more CPUs and we have more RAMs. The size of RAM is increased and the capacity of the processing or processors are also increased. So the actual thing here, what you should remember is, see, when the client is sending the data to the server, the reason is maybe the client computer or PC or system does not have that much capacity, maybe processing capacity, or maybe size, data size to process that. So that is why the data is sent to the server. Or maybe the computation is so much complex, or the application what we need to process the data, it is not installed in the local computer. So the local computer needs to send the data for the application or for the computation, or maybe the computation is complex, to the server. So all the computation is done in the server, the process is done in the server, and the result is back sent to the client. And here, if fault tolerance is there for the resources, if one resource or node fails, what will happen? The main computation should not fail. This is also another purpose of normal distributed file systems, because we have placed 3 computers or 3 servers, 5 servers. If one server fails, so again we will be able to do the computation. The main computation should not fail. Recoverability is there, friends. It means if one job or its part fails, what will happen? You should not lose your data. So these are the requirements what the people go for normal distributed file system. And here now, what will happen if we have the following problems or the following conditions? For example, the data which is huge in size, means ranges from terabytes to exabytes. Whether it is possible to handle this data through normal distributed file system? The answer for this is yes. But What will happen if we have a huge or a large volume of data? It will be handled by normal distributed file system, but it is expensive. How we can say it is expensive? We have to increase the number of processors here, we have to increase the size of RAM, and we have to increase the number of hardwares and softwares like that. And these processors are working parallelly or processing parallelly to execute a huge amount of data. So that will be so much expensive for us. So that is one of the reasons we go for Hadoop instead of normal distributed file system. Another reason is here, like if we have a complex data in nature, what will happen? Different formats. Here, normal distributed file system, friends, it is actually working on structured data. The data is based on primitive data types like integer, float, character. So it can be handled very efficiently and very fast using normal distributed file system. But if we have different data types and different formats, so that will be another problem for normal distributed file system. If we have heterogeneous data like unstructured data, different types like emails, text, images, videos, audios, so it can be handled, but it is so much expensive and it is so much complex there using normal distributed file system. If we are dealing with real-time data, so real-time data, the data which is on the spot, capturing the data, processing the data, and then getting the result, it is so much difficult, and using normal distributed file system, it is possible but expensive. If we have NoSQL, the concept of NoSQL is here. It means the data is unstructured data, the data may be semi-structured data, the data is not structured, so that is called NoSQL data. So that can be handled only using Hadoop environment. If you are using normal distributed file system, I told you friends, it is possible, but it will be so much expensive. You have to keep increasing the number of processors, CPUs, hardware, softwares like that, and that becomes so much difficult and expensive. That is why we are going for the next environment, which is called Hadoop environment. So let's talk first what is Hadoop itself. Hadoop is an open source framework which is designed to process a large volume of distributed data across multiple computers, which is called the clusters, using simple programming model. So from this definition, you can easily differentiate between normal distributed file system and also Hadoop environment. First difference is here, it is open source, it is free of cost. The second thing is, it is actually designed to process a large volume of data. If we have a huge amount of data, the data in terms of terabytes, exabytes, maybe zettabytes, so that cannot be handled efficiently by normal distributed file system, it is better to use Hadoop environment or Hadoop file system. In here also we have different or multiple computers. We don't have only 3 servers, we don't have only 1 server, 3 servers, we will be having multiple servers, around 1000 servers, 100 servers, and we will have multiple clusters, and only using a simple programming model which is called MapReduce. So I hope you understood the difference between normal distributed environment and Hadoop environment. And let's see another here. It is designed actually to scale up from a single server, what we had there in normal distributed file system. Single server, maybe 2 servers, 3 servers, no problem. But here we have, it is designed to scale up from a single server to 1000 servers or machines. Each of them is offering local computation and storage. This is another difference, friends. As I told you there, in normal distributed file system, the client is sending the request to the server. If the server rejects, so nothing will happen. If the server accepts, then the client can send the data to the server, and then the server there, it will be computed, the computation is done, the data is processed, analysis is done, then the result will be back sent to the client. But here in Hadoop environment, what will happen? Everything is local, friends. The computation will happen locally and the storage is there locally. The data is not moved from one computer or system to another system. Everything is locally done. Just the control will be moved from the main server, which is called the master, to the client server, which is called the worker node. Only the control will be moved, not the data, not the computation. Only the control will be moved from the main server to the node server, and the data is already there. The computation will be performed there and the storage is there. So the data may not be moved from one server to another server. This is another difference, friends. I hope you understood these much differences. Now let's see the unique features of Hadoop. From here also you can better differentiate between the two. First, here also we have scalability. As I said before there, so we can increase the number of servers, not to 3, 4, 5. We can change it, or we can see here scale up from single server to 1000 servers. We can have any number of clusters, we can have any number of machines, or 1000 servers we can have. Fault tolerance is there. If one server fails, so again the data can be retrieved from the other servers, because the data is replicated on multiple servers. And also we have recoverability. If one job fails or part of a job fails, again we can recover the data, so the whole data may not fail. Recoverability is there. The data may not be corrupted. And here we have large distributed file system. Hadoop supports large distributed system. It means the data may be in the range of terabytes, exabyte, and even zettabytes. It is fast processing environment, and also it is streaming access. Here we have data consistency is different, because we can have real-time data also. Accuracy is more, consistency is more there. We have streaming access, and it can handle both SQL data and NoSQL data. It means structured data, semi-structured data, unstructured data. Maybe the data is based on primitive data types, integer, float, character, or like that. But here, a normal distributed file system, here the data will be in the form of structured data based on primitive data types, integers, float, character, like that. But here it is handling both SQL data, structured query language, and no structured query language. It is supporting and handling both types of data. Another one, it is low cost. Yeah, definitely I told you it is low cost because it is open source framework, and here we have multiple computers, so it is open source and free of cost. Another one here, the difference is no movement of data. It means the client does not need to send the data to the server. No, only the control will come to the client, and there in the client computer the computation is done, the storage is already there, the data is stored there, only the computation will be done. So these are the main differences and advantages over normal distributed file system. So I hope you understood Hadoop. It is an open source framework which is designed to process a large volume of distributed data across multiple computers called the clusters using simple programming model. And it is designed to scale up from a single server to thousands of machines or servers. And another thing, here we have each server has its own storage and its own computation. Locally will be done everything. Only the control will move from one server to another server. Okay, now let's talk about another thing here, JDK. So as we said, the topic here is, the subject is big data Hadoop with Python. So you will say, why you are installing JDK? So this is the question, yeah, why I'm installing JDK? The reason is, friends, Hadoop is written in Java. Hadoop is written in Java. So it is a Java program. If it is a Java program, how we can run a Java program? So to run a Java program, we have to first provide the environment for Java program, and that is nothing but installing the JDK Java Development Kit. and by installing that we will provide, or the system will provide, a runtime environment for all Java programs. Then the Java programs can be easily run there, executed. There we will be having the loader, the linker, the compilers, everything will be set up. Then the Java programs can be easily executed and run there. And that is the reason first we have to install the JDK, because Hadoop is written in Java, and for executing Hadoop services, so we need to install the JDK or create a Java virtual machine or Java runtime environment. I hope you understood. Now let's see how to install that. For installing the JDK, what we have to do here, first we have to see the services are already updated or not. You have to run this one, sudo apt-get, then we have update. For doing this, let me open the terminal, and for opening the terminal, Control plus Alt plus T I am pressing. So here, yeah, we have the terminal, and I have to check whether the services are updated or not. I say sudo apt, and then we have get, I say update. It needs the password, so I have to type the password. Yeah, it is taking the updates. Yeah, everything's are updated now. The services are updated. Now I have to install this version of JDK. Open JDK 8 I want to install. If I simply run like sudo this one, default one, it will install the other versions. But I want to install this version, that is why I have to type it manually, this one only. So I take the copy, and here in the terminal I want to paste it. Yeah, this version I want to install. Now it is asking me, I will say yes, you install this. So later on, then we can check the version whether it is installed or not correctly. If it is showing as the version, this one JDK, open JDK 8, so we can say yeah, it is correctly installed, and then we can work with them. So here it is saying yeah, done. It means installation is done, everything is ready now. Now let me see whether it is correctly installed or not. I say Java, then I put version here. Yeah, here it is showing me yeah, you have installed JDK version 8 here, and open JDK is 64-bit server virtual machine. So I hope you understood, friends, about these things. So the installation is done, and I say okay, exit. And now here we talked about JDK, why we are installing in JDK, because Hadoop is written in Python, and sorry, Hadoop is written in Java. We have to provide the runtime environment for that, for the programs, for Hadoop programs, Hadoop services, all those things, and that is done only by installing the JDK Java development environment, and that will create a virtual machine and also a Java runtime environment for all Java programs, since Hadoop is written in Java. And then we talked about normal distributed file system, and we talked about Hadoop environment, and I told you the difference between normal distributed file system and Hadoop environment. All those things you have to understand. So I hope you understood this much, friends.